All right, welcome to the week 5 lesson. This lesson is all about linear equations. All right, so let's go ahead and get started. First off, obviously a linear equation is any equation that makes a straight line. When we look at the graph, or if we look at the table, it's sort of as x increases, the y increases by a constant rate. There's 3 forms that we're going to look at. So the first form is slope-intercept. The second form we're going to look at is standard form. Some people call it general form. And the last form that we're going to look at is called point slope. Point slope form. Okay? These are the 3 forms we're going to look at. So let's start off with the first one, slope-intercept form. It is the one that we most commonly use. You've seen the equation. It looks like y equals mx plus b, where m is the slope of the line, and b is the y-intercept. Okay, that's why it's called slope-intercept form, because it involves m, the slope, and b, the y-intercept. So a couple reasons we like it. It's really, really, really easy to graph. Okay, I can use the y-intercept and then use the slope to find a second point, and that's all I need. So it's easy to graph, and it's really easy to extract information. I can look at it, and I can go, oh yeah, this is the slope and this is the y-intercept. Okay, it's really easy to extract information. I can just look at it and tell. All right, so before we get started too in deep, let's look at m real quick, the slope. There's 2 ways to think about it. You can think about it as rise over run. Okay, remember rise is kind of like how far up and down. Run is how far left and right. Okay, so rise versus run. This is really good if you have a picture, if you have a graph or a picture. If you have a graph, or if you're dealing with the equation, if you know the equation, it's really easy to think of rise over run in this case, okay? The other way we think of slope is more of like a formula, y2 minus y1 over x2 minus x1. This is good if you're given 2 points. If you have 2 points, 2 coordinate points, right, an x and a y, x1, y1, and x2, y2, right? This would be point 1. This would be point 2. If you're given 2 points, it's really good to think of slope in terms of that formula. Now, if you think about it, the difference in the y's, right, the change, is how we consider rise. So the rise is really just the difference in the y's. The run is the difference in the x numbers. So these 2 equations are actually very similar to each other. They're definitely related. They mean the same thing. There's different applications for them. All right. So real quick, talking about slope. Anytime a function is increasing from left to right, we say that that is positive slope. Okay, anytime the graph is going downward, we say this thing has negative slope. Anytime it's flat, we say it has slope of 0. And anytime it is vertical, we say it has slope that is undefined. Okay, 0 means because there's 0 rise over some number of run, right? And 0 over a number is 0. Undefined means because there's some number of rise, right? If you pick 2 points, you can calculate the rise, but there is no run. So we're dividing by 0, and anytime we divide by 0, we say that number is undefined. So one really, really important point here, okay, to use this equation, y equals mx plus b. Okay, to use this formula here, it's got to have y by itself. See how it's y equals? It doesn't say 2y. It doesn't say negative y. It doesn't say x plus y. There's nothing on the left side other than the y. So if you've gotten the y by itself, you're allowed to use this form. Okay, so you can only say, oh, the slope is the number right in front of the x, and oh, the y-intercept is this number by itself. You can only do that if y is by itself. If you haven't done that yet, you have to do that. It's not in slope-intercept form until you solve for y. All right, so moving on. Well, let's look at an example. All right, find the slope and the y-intercept of the following equation. So we have 2x plus 3y equals 12. Okay? So it's tempting to go, oh, the slope is the number in front of the x. So slope is 2, and y is the number without the x. So that's 12. But you don't get to do that yet because we haven't solved for y. So what I have to do is I have to get y by itself. So I'm going to take away 2x from both sides. 2x minus 2x is 0. That leaves me with 3y. Now over here, I can do 12 minus 2x. Okay, sometimes if the 2x is negative, we put it after the number. Sometimes it's written before. It doesn't matter what order it's in. It's just whatever number is with the x is going to be the slope, and the number that's not with the x is going to be the y-intercept. Finally, we're going to divide everything in here by 3. Those 3's are going to cancel and leave us with y equals 4 minus 2/3 x. Now notice I bring that x out to the side so I can really see that number that's in front of it. Otherwise, you might think, oh, it's just a 2, right? Because there's a 2 right in front of the x. But that's not the case. It's actually 2/3. Okay? All right, so we've solved for y. Now I can extract that information. The slope is the number that's in front of the x, so the slope is negative 2/3, and the y-intercept is 4. It's the number by itself. Okay? So that's how you would answer that question. All right, now let's say we want to graph this thing. Okay, that's a very common thing we want to do as well. So I've got this graph. Where do I start? Okay, I start with the y-intercept. So remember, this is my y-axis, and the location on the y-axis where the graph crosses it is called the y-intercept. And since the y-intercept is 4, I know that up here at a height of 4, there's one of my points. That's the y-intercept. Okay. Now I use the slope to find the next point. And so what I'm going to do is I'm going to use rise over run. Remember, I'm dealing with an equation. When we're dealing with an equation, we think of it as rise over run. So I have negative 2/3. Now you have to put the negative with one of the numbers. So you can think of it as negative 2/3 if you like. Okay, and I'll show you the other way, and it works too. So my rise is the top number. So rise negative 2. Remember, rise positive would go up. Rise negative would go down. That means negative 2 means we're going to go down 2. So I'm going to go down 2. So bam, bam, right? I've gone down 2. Now I need to run positive 3. Well, which way is positive 3 if I run? It's going to be to the right, right? Positives are to the right, negatives are to the left. So now if I count over 3, I'm going to go 1, 2, 3. There is my second point right here. Okay? All I need is those 2 points. That is going to draw the equation right here. So the line that goes through those 2 points, that's my graph. Now remember I was saying negative 2 over 3. I could also think of it as 2 over negative 3. It doesn't matter as long as I only use one negative sign. If I were to use 2, it would be a negative over negative, which would actually be a positive number. And we're dealing with a negative slope here, so only one of the numbers should be negative. Well, let's go back up to our starting point, okay? I'm right here at my starting point. That is the coordinate, or the y-intercept of 4. I'm going to go up 2 because that's a positive rise. So I go boom, boom, that's up 2. And then I'm going to go left 3 because a negative would take me to the left. So if I go over 1, 2, 3, I'm going to find another point. But if you see, that point is still on the line. So I'm going to still graph the same line. So it doesn't matter which number gets the negative, but make sure only one of them gets the negative when you're graphing a function that's linear like this. All right. So a couple of weird examples. Let's look at the equation y equals 5. Okay. Y equals 5 is in y equals mx plus b form. Okay. Y equals mx plus b looks like this, and I've got y equals mx plus b actually. Okay. So the question is, what is the slope of this line, and what is the y-intercept? So again, looking at how this works, the number with the x, the number attached to the x, is the slope. Well, there's not a number with an x here. So you have to kind of almost imagine it being there as a 0x. Okay? Yeah, it's 5 plus 0x. That makes sense, right? So m is actually going to be 0. So this has 0 slope. What is the y-intercept? The y-intercept is the number that's not attached to the x, so we're going to say the y-intercept is 5. All right, so we would know that the y-intercept is positive 5. That's where it crosses, and it has slope of 0, so it's flat. So y equals 5 is that flat line right there. Okay, next example, y equals 1/2 x. Okay, so y equals 1/2 x. Is this in y equals mx plus b form? I think it is. We've got y by itself, so it's in y equals mx plus b form. What is the slope of this line? Well, remember, the slope is the number in front of the x, so the slope is 1/2. What is the y-intercept? Well, the y-intercept is going to be the number that's not with the x, and you have to imagine it being there. It's a +0. You didn't have anything there. So the y-intercept is 0. So if I were to graph this, I start with my y-intercept, then I use my slope. I go rise 1, run 2. That's rise 1, run 2, right? Up 1, over 2. That's going to give me my second point, and then from there I draw my line, okay? All right, let's go to standard form. That's our next form. All right, standard form. All right, so standard form looks like this. AX plus BY equals C. And sometimes they write it as AX plus BY. I'll just put plus C, even though I should put minus C. But basically, there can be another number over there. I know that's probably hard to see. I have to move that out of the way. So that's another way you can write it. It could be everything on one side equal to 0, or the number, the constant term, could be on the right side. But either way, that's the same kind of thing. Okay. So here's about standard form. First thing you got to note, there's a B here, right? We had a B when we were talking about this form, right? There was a B in that form. So don't think these are the same B's. It's unusual, but mathematicians usually like to use the same letter if it means the same thing. But in this case, it's actually a different B. Do not think of it as the B from slope-intercept form. It's not the y-intercept. Okay, so here's some rules that you have to follow when you are dealing with standard form. First off, A, B, and C, they can't be fractions or decimals. Okay, they're not allowed to be fractions or decimals. What that means is they have to be integers, positive integers. Integers, okay. So they have to be positive integers. What that just means is we're not allowed to have a fraction or a decimal, okay? The other rule is that A has to be positive, okay? A is positive. So in other words, the number that goes with the x, right, because A is attached to the x, that number has to be positive. So you'll never have negative 3x plus 2y equals 10. You won't have that. That's not in standard form because of that negative 3, all right? It's pretty easy to fix that. You just multiply the entire thing by -1. That would make this 3x minus 2y equals -10, right? It just switches all the signs. Negatives become positives, positives become negatives. Now this would be in standard form. So these are the same lines, just one is following all the rules, okay? And then as far as getting rid of fractions, if you had 1/2 x minus 2/3 y equals 1, you would multiply everything in here by 2 first, because the 2 will cancel with the 2. You'll have to distribute the 2 to here, so times 2 times 2. That would leave you with 1x minus 4/3 y equals 2. Then you do the same thing with the 3. Distribute a 3 to everything. That's going to make 3x minus, now remember the third will cancel with the 3, minus 4y equals 6. Now we're in standard form. So if you're given something like this with fractions or decimals, you've got to do this process of eliminating those denominators. And it could be with decimals too. I've seen it before where it's decimals. Just multiply by powers of 10 until those decimals become whole numbers. And if there was like a common factor, like if it was 10x plus 20y equals 60, you would want to reduce that by dividing everything by 10, make it x plus 2y equals 6. You do want these to be in like a reduced form. But that's about all I can tell you with standard form. Although I do want to talk about graphing. So if you had, let's say you had something like 5x minus 3y equals 30, okay? If you want to graph this, the easiest way to graph this is not to solve for y and put it in a different form, right? If you solved for y, you could look at the slope and the y-intercept just like we did in that previous form. But this is actually pretty easy to do. You look at the x and y intercepts, okay? So what you have to remember is an x-intercept is the location on the x-axis where the line crosses the x-axis, okay? What we know about every x-intercept in the world is that there's some kind of x number, right? You travel over to the x. and then you go up or down for the y number. Well, it's not up or down, it's right at 0. So every y value on any x-intercept you're ever looking at is going to be 0, okay? Think about a different line here. This line here, right? This coordinate maybe is -3, 0. This coordinate is like 4, 0. This is 0, 0, -1, 0, -4, 0, -5, 0. Every x-intercept has a y value of 0. So what you do is you let y equal 0, and then you find the x number that you're looking for, okay? So what you can do in this equation is I would say, okay, let y be 0. If y is 0, this whole term here disappears, okay? This is gone. You're left with 5x equals 30. Now what number works here? 5 times what is 30? Well, it's going to be 6, okay? That's pretty easy. So let's do the same thing. Now this is the x-intercept because we let y equal 0. So now we're going to let x equal 0, okay, and we're going to find the y-intercept. So we just do the same thing, okay, except this time, right, I'm going to have 5x minus 3y equals 30. This time I'm going to let x equals 0. So this whole thing goes away because 5 times 0 is 0. And so it just disappears, okay? It pretty much just goes away. So you're left with minus 3y equals 30. If I divide out the -3 on both sides, right, the process of solving, I get -10 for y. That means this is -10. So I've got 2 coordinates, and that's all I need. If I have 2 coordinates, I can graph a line. So I just graph my 2 coordinates. 6, 0. Okay, this coordinate right here is 6, 0. I got that from up here. Then I use 0, -10. 0, -10 is right here. 0, -10. And it's the line passing through those 2 points. That's it. Okay, so anytime you want to graph something in standard form, it's just as easy to do x and y intercepts. It's really fast, and it saves you from having to convert it into another form and then do the graph. It's just the best way to do it. Okay, let's look at an example. All right, so if you want to find the slope if you're asked to find the slope and the y-intercept, or just even the slope, okay, of that same form. I'll look at that same example, 5x minus 3y equals 30, okay? If you're asked to find slope and y-intercept, you need to put it in slope-intercept form. That means you have to solve for y. Solve for y. So you got to get the y by itself, okay? So how do we do that? Well, I get rid of things that are around it, like this 5x. I subtract that 5x away, and I'm left with -3y equals 30 minus 5x. Okay? Next step is to divide out the -3. So I have to divide everything by -3. I'm left with y equals -10 plus, because that's a -5 divided by a -3, 5/3 x. Okay, so once I've put it in that form, then I can say, okay, the slope is 5/3 and the y-intercept is -10. Okay, now just think about this. We already graphed this, so I could graph it now too. All right, the y-intercept is -10, that's down here, and the slope is 5/3. So go up 5 over 3, here's your point. Up 5 over 3, up 5 over 3. So you'd see it's the same graph, but if you're just graphing it, I think it's easier to use the y-intercepts. If you're actually asked to find the slope and the y-intercept, then you got to solve for y. You got to change forms. A lot of the times they give it to you in standard form, and they want you to switch it to another form to utilize that form's capabilities. Okay? All right, looking at the third form. Our last one is going to be the point slope form. All right, now point slope form looks like this. Y minus y1 equals m times x minus x1. Now, if you look back at all the other forms, they all have x's and y's in them, right? These are linear functions in terms of x and y. So this is going to also have an x and a y, but you'll notice this one has 2 x's and 2 y's. You got to realize that the x1 and the y1 are actually one of the coordinates on the graph. So if I know a coordinate on the graph, I plug it in for the x1 and the y1, not the x and the y. The x and the y are variables. When you write it, you have to leave those as variables. Now this m is the same m that we've always talked about. This is the slope. Okay. M is the slope. All right. Don't forget x1, y1. That is a coordinate or a point that is on the line. This is a coordinate or a point on the line. It has to be on the line. All right, this comes from the slope formula. If you think about the slope formula, it's basically x minus x, or excuse me, y minus y over x minus x. If I multiply both sides by the x thing, I get this formula, okay? That's where this comes from. If you look at that, that sort of looks like the same thing. It just comes from the slope formula. So if you can remember the slope formula, this is just as easy to remember as well. Okay, so if you're given the slope and a point, you just plug those numbers in, you're good to go, okay? A lot of the times they want you to plug them in and then change forms, and that's easily doable. We will go ahead and look at something like that. All right, so let's look at an example. All right, what is the y-intercept if the slope is -1/2 and the coordinate -2, 5 is on the line? We want to know the y-intercept. Now, what do they give us? What information is given in the problem? Slope and a point. I would always, if you're given the slope and a point, use point slope form. It's so easy to use. So we do y minus the y value, the actual y coordinate, okay? The y coordinate in this problem is 5. So y minus 5, okay? That's going to equal m, which is the slope, -1/2 times x minus, now what's the x number? The x number is -2, so I'm going to write -2. Now why does that turn into a plus? It's because we're subtracting a negative. Don't forget, in the formula, all right, look up at the very top, the formula has a minus sign in it. You've got to put the minus sign there, and then if you're subtracting a negative, you've got 2 minus signs, so they convert into a plus. But you've got to write the negative sign from the formula. Now, we're asked to find if it just said find the equation, this would work. This is the equation of the line. But it asks for a little more information. It says, what's the y-intercept? So if I'm thinking y-intercept, I should think, oh, slope-intercept form, because that's the one that tells me the intercept, the y-intercept, okay? So then what I do is I just simplify. So first thing I do is I distribute. I multiply this -1/2 inside both of the terms. So I get -1/2 x minus 1. Okay, a half times 2 is 1. Negative times positive is a negative. Okay, so my last step is to get y by itself, because remember, I'm not allowed to use that form until I've got y by itself. That makes this +4. That means my y-intercept is +4. Okay. All right. That's that one. All right, so let's try another example. Write the equation in point slope form if the coordinates 3, 6, and 2, -1 are on the line. Okay, so we want to write the equation in point slope form. All right, first of all, point slope form. I need points and slopes. I have points, I got 2 of them. I don't need 2, I only need 1, which is fine. I can have as many as I want, but I really only need 1 of those. But I do need the slope. So how am I going to find the slope if I'm given 2 points? Well, I use the slope formula. So y2 minus y1 over x2 minus x1. So the difference in the y's over the difference in the x numbers. So the y numbers, well, y2 is -1, right? I'm getting that from the second point. I have to subtract because there's a minus sign in the formula. I have to put a minus here. Now y1 is a positive number. It's a +6. So I'm just going to write -6. Okay? Divide the x numbers. x2, that's 2. It's the second x that I see in my coordinates, right? First point, second point. So the second x is 2. Subtract the first x, which is 3. That's going to give me -7 over -1. 2 negatives when I divide turn into a positive, and 7 divided by 1 is 7. So I know the slope is 7, and I know one of the points. So I can write it in point slope form. So here's the formula. Y minus y1 equals m times x minus x1. Y minus y1. Well, there's two different y1s. I'll go ahead and stick with the first one that I have, y minus 6. Okay, my first y value is equal to the slope, which we just found was 7, times x minus x1, which is 3. That's it. That's the equation in point slope form. Now, if they asked the same question, but they said, write it in slope-intercept form, then I would just solve for y. I would distribute the 7 and then add the 6 to both sides. And that would give me slope-intercept form. If it said write it in standard form, I would do the same process, but I would just make sure that my 7x, when I moved it over, I'd switch it to a negative, and then I'd multiply by -1 at the end to make that a positive 7, and the y already has a coefficient that's not a fraction. So I would just put it in that form. You just put it in whatever form they ask you to put it in. Okay? All right. So this is really, really common. They're going to give you these questions guaranteed on the essay or the ACT. It's going to say find the equation of a line. Okay? And they're going to give you two things. There's one where they give you the slope and 1 point. So they could give you the slope and 1 point, or they could just give you 2 points. Okay, this is actually kind of like the last example that we worked, but I want to really put it down on paper here. Okay, so the slope and a point. So they could give you, all right, 3, 2, and the slope is -4/7. Okay, they'll say find the equation of a line. Well, use point slope form because we're given a point and the slope. So you plug it in, y minus y1 equals m times x minus x1. Okay, and then you either leave it like that, or if they ask for a different form, then you convert it. Okay, if they give you 2 points, 1, 2, and 4, 5, right? Same process, but we don't have the slope. We have to actually calculate the slope first. So once I find the slope, then I can use y minus y1 equals m times x minus x1. Then I use that formula. Okay, so let's write this down formally. So first thing you got to do in these kind of problems is find the slope of the line. Okay, that's if you don't have it. So if they give it to you, you don't have to worry about it. But if you don't have it, then you're going to have to calculate it. Okay, the second thing is you're going to plug in the slope and one of your points into the point slope formula. Okay, that's the y2 minus y1 equals m times x minus x1. Third thing you're going to do is put it in the right form. You're going to put it into the correct form, whether that's y equals mx plus b, or maybe you just leave it like you had it, that's point slope form, or maybe you put it in standard form, but you put it into the right form. Usually that's y equals mx plus b, so usually you're going to solve for y, but that's not always the case. All right, so let's look at a couple of special lines. Okay, we've talked about the 3 forms. Let's look at some special lines, kind of some special cases lines. All right, so let's look at the equation of a vertical line. Okay, let's make a vertical line right here. I want to know the equation of that line. Okay, well, let's look at the points here. Let's say this is 3, 0, and this is 3, 5, and this is 3, -6. What do you notice about all those x and y numbers? Do you see that the x number is always 3? It doesn't matter what the y number is, actually. So the only thing you need to know is the x number. The x number is 3. That is actually the equation of a vertical line. X equals 3. Every point on this line satisfies that equation, because when you plug in the x and y values into here, it says something true. You plug in x equals 3, you get 3 equals 3. There's no room to put the y value in. So no matter what, if you plug in x and y into that, you'll get a true equation, which is what we said a solution is, when you plug in a number into an equation and it says something true. So really, you just got to know that the x number is 3. All right? How about the equation of a horizontal line? Okay, so the horizontal line. So let's look at that. So we have horizontal line right here. And let's say these coordinates are 0, -2. This is 10, -2. This is -8, -2. Those are all the coordinates for that horizontal line. So what do you notice about this? Look at all the y numbers. See how they're all -2? It doesn't matter what the x is. It just matters that the y is equal to -2. That's the equation of that horizontal line. Think about it. When you plug in this number into this equation, does it say something true? Plug in -8 for x and -2 for y. Well, there is no place to put in x, but if I plug in -2 for y, it says something true. Therefore, this number is a solution. Anytime you do this, it's going to work on this line. 0, -2, plug it in, it's going to work. 10, -2, plug it in, it's going to work. So that's kind of an idea of these special lines and why they work. But how do you remember? Just remember this, the vertex, right? That's a word we use in math a lot when we talk about parabolas. Also, what's the line when you're on a boat and you're looking out on the ocean, the very point where the water meets the land, or the water meets the air? That's called the horizon. Okay? Vertex, vertical lines are always x equals a number. Right? Something like that. Horizon, horizon, y equals a number. Horizontal lines are always y equals a number. So y equals 3/2, or y equals -2, or y equals 16, right? These are all horizontal lines if they're y equals. They're all vertical lines if they're x equals, okay? Easy way to remember that is vertex and horizon. All right. So one really important thing you got to know how to do, this is almost a guaranteed question on the ACT, is talking about, are two lines parallel or perpendicular? So we're going to talk about that. Parallel versus perpendicular lines. So how are you supposed to know if two lines are parallel or perpendicular? All right, if two lines have equal slope, what do you know about those lines, right? Think about it. This one goes up 3/1, up 3/1, so it goes like this. If this line goes up 3/1, it's going to look like this, up 3/1, up 3/1. Same thing, okay? Those lines are going to be parallel. So if two lines have equal slope, we're going to say those lines are parallel. Okay, they're parallel to each other. Now, perpendicular is a little bit weird. If two lines have what we call negative reciprocal, and what that really means is the fraction flipped upside down. Negative reciprocal lines are perpendicular. Okay, so I'll look at an example here. 7/3. If one line has slope 7/3, it would need another line to have slope -3/7 to be perpendicular to it. Okay, opposite sign, one positive, one negative, and it's flipped upside down. Now, what about the number -3, right? What if you flipped it upside down? Well, what is it? It's not even a fraction, so how could you flip it upside down? Well, it is a fraction. Every number is a fraction in disguise. This is -3/1. So when you flip it upside down, it turns into 1/3. So remember that. If you have 7, the reciprocal would be 1/7. So one positive, one negative. Now, let's just say you have one that's 2 and one that's 1/2. Are they parallel or perpendicular to each other? Well, they're not parallel because they're not equal. And are they perpendicular? No. One is 1/2 and one is 2. They're not negative reciprocals. This is called the neither case. Okay, this is neither parallel nor perpendicular. All right, so what you got to do is you got to basically, you'll be given two equations. You got to solve for the slope, which means usually you have to put it in y equals mx plus b form. Okay, once you find the slope of the two lines, you just compare them. If they're equal, they're parallel to each other. If they're perpendicular, they're going to be negative reciprocals of each other. If it's none of those two, they're not. They're just regular intersecting lines, right? They intersect like that. Perpendicular, right, means that they intersect at 90-degree angles. That's a special type of intersection. All right, so let's try an example. We have two equations, y equals 6x minus 2 and 6y equals 2 minus x. These are two lines, two linear functions. I want to know the whether or not they're parallel, perpendicular, or neither. Okay, so let's find the slope. What's the slope of the first line? Slope of the first line is 6. Okay, that's the first line slope. Now the second line we don't know the slope of because it's not in y equals mx plus b form. The y is not solved for. Now if we just divide everything by 6, we'll be able to do that. Don't forget the number in front of the x is actually the slope. So we're looking right here, that's negative 1/6. Okay, so are those negative flips of each other? Yes, those are negative reciprocals. So we would say these two lines are perpendicular to each other. Okay? All right, let's look at one more example of this type because there's this special case that I want to go over. So 3x plus 2y equals 6. There's the first line. Second line is negative 6 minus 4y equals 12. Okay, so what's the slope of this? Remember, you don't actually even have to worry about the 6 here, but I'll go ahead and put it anyway, minus 3x. If I divide everything by 2, I'm going to get y equals 3 minus 3/2 x. So the slope is negative 3/2. Do the same thing here. Okay, I'm going to add my 6x over to both sides. Negative 4y equals 12 plus 6x. Okay. Divide everything by negative 4. Divide by negative 4. Divide by negative 4. I get y equals negative 3 minus 3/2 x. All right, so real quick, I meant to put negative 12 here. So if you can change that to a negative, all that does is make this a positive 3. Okay, so it looks like these are parallel, right? If we look at the slopes appear to be the same. Let's graph the first line. Y-intercept of positive 3, down 3 over 2. There's the line, right? Down 3 over 2, right? Rise negative 3, run 2. Let's look at this one. Y-intercept of 3, down 3 over 2. We have that line there. This is interesting. They're actually the same line, okay? So this is like a weird case, but this is definitely something they'll ask you on the test in this type of question. These two lines, we say, coincide with each other, okay? What that means is coincide. They are the same line. So if you do this process of finding the slope where you solve for y, and you notice that not only is the slope the same, but the y-intercepts are the same, it's the same line. So you got to be careful of this kind of case because a lot of people will solve and go, oh yeah, they're parallel to each other, but they're not. They're the same line. So if they're the same line, we say that these two lines coincide. It just means, yeah, they're basically the same. Okay? All right. Moving on. All right, so let's talk about systems of equations. We're pretty familiar with linear functions now. Let's start looking at what we call a system of equations. So when you have two or more equations, okay, and they're on the same graph, we call it a system. So here's the idea. You have one line here, and you have another line here. All right, this is a system of equations. So what we want to be able to do is we want to be able to say, okay, what is the solution to the system? Because think about this point right here. This point is on the blue line. So this point is a solution to the blue line. But is it a solution to the green line? No, it would have to be on the line to be a solution. Okay, look at this point down here. This is a solution to the green, but it's not a solution to the blue. This point here is a solution to neither. It's not on either line. But you can tell pretty quickly that this point here is a solution to both. So this point right here is very special. We call this the solution to the system. It's a point that solves both equations at the same time. It's a solution to the system. And this is a big thing they're going to ask on the ACT for sure. Okay, so how do you know if something's a solution, right? Let's say we have this linear equation right here, x plus y equals 10. I want to know, is 0, -1 a solution to that equation? Well, it's easy to find if it's a solution. You just plug it in. Plug in x equals 0. You plug in x equals -1. And you see, does it say something true or not? This is not true. That means that point is not on the line, so it's not a solution. So that's kind of the idea here, is that we're going to be given two equations and we're going to want to solve the system. So remember, we're looking for this intersection point, or a point that solves both equations simultaneously. It's got to be at the same time. So a point that solves the system at the same time, we're going to call a solution. All right, so let's look at some strategies to solving a system. All right, so here's some strategies to solve a system. First one we have is called elimination. Okay, this strategy of elimination is one that's pretty popular. We use it all the time when we're solving systems. Let's look at an example. 3x minus 2y equals 12, and minus 6x plus 3y equals -24. Okay, so first of all, what is elimination and how does it work? So there's a couple things you're allowed to do. You're allowed to multiply an equation by a number, okay? You have to multiply every single piece in the equation by a number, but that doesn't change anything, okay? So if I were to take this first equation, this 3x minus 2y equals 12, and I were to multiply everything in there by 2, that would give me 6x minus 4y equals 24. Now, why would I do that? Well, let me write the second equation next to it, and I think you might see why. Okay, first thing you're allowed to do is multiply an equation by a number. That's a allowable move when you're doing this kind of process, okay? Now, the second thing you're allowed to do is you're allowed to add the two equations together. So what happens when I add them vertically, okay? Like we do, you know, old school, like 5th grade addition, right, by columns. 6x plus a -6x is 0x. Okay, it's gone, 0x. Basically, they cancel. This is why we use elimination, because when I add the two equations, one of the variable eliminates itself. It disappears. Okay, so that leaves you with -y equals 0. Well, if I solve for y, if I divide by -1 on both sides, I get y equals 0. Okay, that's half the battle, right? I'm finding this intersection point, so I need an x and y coordinate. I found the y coordinate. How do I find the x coordinate? You go back up to the original equation, 3 times x minus 2 times y equals 12. And notice instead of y, what did I put? Put a 0, because y and 0 are the same thing. We found out y is equal to 0. So by doing that, I can get a very simple equation, 3x equals 12, which means that x is equal to 4. So that means my solution to the system is the point 4, 0. A lot of the times we write it as a coordinate. You could see it as x equals 4, y equals 0, but chances are you're going to see it as a coordinate. Okay. All right. So why would I choose elimination here? Why was elimination a good choice? Let's actually look back. After we go through this three strategies, we'll talk about why we chose that. Okay. Next strategy is called substitution. Okay. Let's look at an example here. We have x equals 4 minus y, and we have 2x plus 6y equals 16. Okay. So substitution is all about solving for one variable in one of the equations. So look at that top equation, x equals 4 minus y. X is solved for, all right? So that means x and 4 minus y are equal to each other. They are the same thing. If you gave me x dollars and I gave you 4 minus y dollars, we would have given each other the same amount. It's a fair trade. Well, if it's a fair trade, you can substitute, okay? So what we do is we solve for one of the variables in one of the equations. It doesn't matter which one. But then you have to substitute into the other equation. Don't substitute into itself, okay? So I'm going to write the second equation. 2 times x plus 6y equals 16. Now notice I left a little space there. What am I going to put in there? Well, whatever is equal to x, and x is equal to 4 minus y. So I replace that, okay? Now what I do here is I distribute, combine like terms. Basically, I solve for y, okay? So 8 minus 2y plus 6y is equal to 16. I have like terms. Those are things that are on the same side that are the same type of thing. So I can combine them together to make a 4y. So I have 8 plus 4y equals 16. Keep solving, right? I just take away 8 from both sides. I'm trying to get the y by itself. I get 4y equals 8. When I divide both sides by 4, I get y equals 2. Halfway done. Remember, we're looking for the intersection of these two lines. So I need an x and y coordinate. I found the y coordinate. Well, how do I find the x coordinate? Well, go back up, plug it back in to this top equation, okay? I'm going to say, okay, x is equal to 4 minus y. Well, what is y? We just found out that y was equal to 2. So 4 minus 2, so x is equal to 2. Well, remember, you'll either see x equals 2, y equals 2, or you'll see it written as a coordinate point, 2, 2. Okay, works either way. All right, so remember, solve for one variable and then substitute it into the other equation. All right, let's look at the third strategy. Third strategy is using a calculator. All right, so let's say we have y equals 6 minus x, and we have y equals 12 plus x. I want to find the intersection of these 2 points. Now, you could use substitution here, right? Since one of the variables is solved for, it's actually really easy to do to say, oh, well, 6 minus x equals 12 plus x. That would find x, and then you back substitute to find y, and you're done. It's pretty easy, and I would use that method for sure here. But the reason I'm showing you this is because I want you to be aware of some different strategies. Okay, so here's the strategy. You graph both lines on your graphing calculator, okay? Then you find the intersection, and I'm going to show you how to do that. And I'll write down the directions of how to find the intersection as soon as I show you how this works. All right, so you're on your graphing calculator, go to y equals, okay, and you clear everything out, and we're going to type in the 2 equations. So 6 minus x, and then 12 plus x. We're going to graph them. Bam, there we go. There's the intersection point. So I can almost guess. It looks like -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like -3, 9, but I want to be sure. First off, the table is an easy way to find out. Look at -3. When x is -3, you see how they're both 9. If they're the same y value, they're intersecting. Look at 3. See how 3 is 3, 3, and 3, 15? Look at the graph. At 3, one's at 3. That's the height of 3. The other one's way up here at 15. Yeah, they're not intersecting if they have different y values. They're only intersecting if they have the same y value. So that's a pretty good indicator that -3, 9 is my solution. Now, let's say it's a fraction or you don't see it on the table, or maybe you just don't like the table that much. You're not feeling comfortable with it. I'll show you how to do it on your graphing calculator. Second, trace. That's the calculate button. Okay? Look at number 5. Intersect. Oh, the intersection of these 2 lines. So go down and hit 5. Now, basically, all you do is hit enter, 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 and it's going to pop out this intersection of -3, 9. So second, calculate. Number 5, enter, enter, enter. Let's write that on here. Second, trace, and then enter, enter, enter. So times 3. You want to do that 3 times. Okay. All right, so that's not terribly difficult. Let's go back and look at the 3 examples, though. So why did we choose elimination here? Why was that a good choice? Why didn't I solve for a variable and plug it in? Or why didn't I use my calculator? What made me choose elimination? You got to look at the beginning, okay? When you're looking at this from the beginning, I notice right now that 3x and -6x, 3 is a multiple of 6. 6 is a multiple of 3. Meaning, if I can multiply by 2, I can change it to where the 6x and the -6x, when added, will disappear. So if you can easily multiply one of your equations by a number, or sometimes you have to multiply both. Like I could make the y's go away. If I multiplied the top equation by 3, that would give me -6y. right? If I multiply the top equation by 3, that would give me 9x minus 6y equals 36. And then the bottom equation multiply by positive 2. That would give me 12x plus 6y equals negative 48. See how now I've lined up my y's to disappear? So somehow you've got to look and see, oh, look, I could easily make these variables disappear. You got to make one of them eliminate. That's why it's called elimination. So whichever way you choose, that's a good method. If you can see, oh, I could turn this into where one of the variables disappears, that's a good reason to use elimination. Okay? Why use substitution? If you've got one variable solved for, substitution is an easy idea. You just substitute, you're ready to go. Or if it's really close to being solved for, like if you have x plus 1 equals y, then yeah, it's really easy. Well, let's say y plus 1. It's really easy to take away 1, and now your x is by itself. Okay? If it's quick to solve for one of the variables, substitution is a great way. Finally, a calculator. If you have y equals and y equals, it's easy to type those into your calculator. You don't have to do a lot of work, so that's a good reason to do that method. Okay. I suppose I do want to have to show you something here. It's possible that you have parallel lines like this. That's a weird case, but it's possible. So there would be no solution to the system. There's no point on there that's on point on both lines. So what would happen is you would do one of these methods, right? You would do elimination or substitution, and you'd work it out, and you'd distribute, and you do all this work, and you get something like negative 16 equals negative 16 at the bottom. All your variables disappear. If both your variables disappear, you're in one of the special cases. One of the special cases is that you get something true at the end. And one of the special cases is that you get something false. So what could happen is, remember we talked about this coinciding thing? It's possible that the lines coincide. If they're the same line, then we're going to have some weird things happen. If they're parallel, we're going to have some weird things happen. So let's say you do one of these methods, you substitute or you eliminate variables, and you get something like this, something that's not true, okay? This right here is always true. Negative 16 equals negative 16 no matter what x I plug in, no matter what y I plug in, okay? Well, every number is a solution. Every number on the line is a solution in this case. When they're the same line, you're going to get something true, okay? They coincide when this is equal to this, when the left side equals the right side. When you get something not true, what that really means is this never works, right? This never works. And it will never intersect if they're parallel. So those are the special cases. All right, moving along. I know we're doing a lot today. This is one of the long days. All right, so it's possible that when you're solving systems, right, it says find the solution, or it'll say find the solution to the system, or it'll say find the intersection point, right? Those are the same thing in this case, okay? So intersection point or the solution, it's the same thing. Sometimes they ask you to find something like an expression. Find 3x plus 5y, okay? Given the system x minus 3y equals 20, and x plus 4y equals 60. Now, two ways to do this, okay? You can just solve the system like normal, okay? Find your x and find your y, and then take those values and plug them into here and find the value of that expression, okay? That's pretty easy to do. So solve it like normal, then plug in your x and plug in your y to get a number. Alternately, you can look for some sort of combination of these two equations that add or subtract to equal 3x plus 5y, okay? So in this case, if I were to take one of this equation here, just take one of them, okay? That's x minus 3y equals 20. And then I were to take two of these equations, okay? So two of them, I would have to multiply everything in here by 2, okay? What happens is, right, when I multiply everything in here by 2, I get 2x plus 8y equals 120. And over here, right, I get x minus 3y equals 20. What happens when I add these two together? I get 3x plus 5y equals 140. There's my answer right there. 3x plus 5y is 140. So it saves you that time. So look out for this. When they ask you something weird with a system, try to see if you can add some combination of these two equations to equal the expression that they give you. And then whenever you do that, on the right side where they're equal, the numbers will actually give you the answer pretty quickly. So that's kind of a shortcut. Because solving the system would take a little while and it would work fine, but if you can look out for this shortcut, it's going to save you some time for sure. All right, moving on to the next topic, inequalities. Okay, so when we're looking at inequalities, just remember it's like an equation, but it's got a less than, greater than, or greater than or equal to, or less than or equal to. It's something with one of these four signs. Okay, an equation with one of those four signs. There's just one thing you have to remember. You treat them like normal equations. You can add 5 to both sides. You can subtract 3x from both sides. You can divide both sides by 2. You can do all those normal equation solving methods, right? Those algebraic rules. But if you multiply or divide by a negative number, okay? It's got to be a negative number, and it also has to be multiplying or dividing. If you add or subtract the negative number, it doesn't count. If you multiply or divide by a negative number, you must switch the sign. Now, what sign am I talking about? I'm talking about the less than or. So if I had negative x is greater than 10, and I divide both sides by negative 1, I get x and I get negative 10, but I have to make sure that I switch the sign. Okay? If I have x divided by negative 7 is greater than or equal to 2, and I multiply both sides by negative 7, those are going to cancel, and I get x and I get negative 14, but I have to make sure I switch the sign over. Okay? That's just one of those rules you have to remember. If you multiply or divide by a negative number, you've got to flip those signs over. All right, so we always have graphs with inequalities. So when it's one variable, the graphs look something like this. You'll have, a line with a shading going on. If it's a compound inequality, you might have two different parts. And don't forget, when you're looking at your answers, you can test points. You can guess and check. Like you can say, oh, this number over here, this negative 10, looks like it's a solution. So when I plug it in, it should say something true. Now with inequalities, you'll have things like this, 10 is greater than 2. That is a solution. Whatever number you plugged in is a solution because 10 is greater than true. If it says something true, you know that number you plugged in is a solution. Okay. Now you can use your calculator to do inequalities. You just have to graph the left and the right side, just like we did on week 2. So if you need to look at that, go back to week 2 and look at how we graphed the left side and the right side, and we compared when the left side or the right side is bigger or smaller than the other side. Okay. So one variable is pretty easy. It's something you've seen a million times. I'll just do a real quick example here. All right, it says solve the system, or excuse me, solve the linear inequality. So you just solve it. You add 7 to both sides. You get negative x is greater than or equal to 22. Divide by negative 1, which means we have to switch the sign over. X is less than or equal to negative 22. You look at this graph. Less than or equal to, remember that means a closed line. If it's less than, it doesn't say equal to, you would have an open line. So the difference would be this is x is less than 22, no equal to. It's not allowed to equal that. That's why we have an open circle showing it's not allowed to actually equal 22, but it's got to be less. Okay? All right, so let's look at something more interesting. Let's look at two variable. So here's how two variables works in inequalities, okay? You might have something like 2x minus 3y is greater than negative 12, okay? This looks like standard form of a linear function, right? You've got the x and the y on the same side, the number on the other side. So what I would do is treat it just like an equal sign for just a moment. So graph the line. All right, so what you do is you let the less than or equal to, the greater than or equal to bit, you let it just be an equal sign for just a brief moment. And I would use intercepts here, but you don't have to. So there's two things. There's a dotted line versus a solid line. And that all has to do with dotted lines or when it's less than or greater than. That's dotted. Solid is when it's less than or equal to or greater than or equal to. That's when it's solid because you're allowed to equal the line. Okay, so first thing you do is you graph the line. And let's do that on this example here. All right, so if I'm going to graph the line, I'm going to make a little XY chart. I'm going to let X equal 0 and see what Y is, and then I'm going to let Y equal 0 and see what X is. Okay, so first thing, let X equal 0, right? Cover up the X, and what does Y have to be? Y has to be -4. Okay, so that tells me that Y is -4 when X is 0. Okay, -4. Then I do the same thing. I'm going to let Y equal 0, okay? And then I can find out what X has to be. So when Y is 0, X has to be -6, right? Because 2 times -6 would equal -12. So there's my 2 points, 0, -4, that's right here, and then -6, 0, that's right here. Now remember, I'm graphing the line, so I'm pretending it's an equal for just a moment, but I go back and then really I'm looking at a less than or greater than, which means I'm going to have a dotted line. I'm not actually allowed to equal that line. It has to be greater than that. All right, now how do you know which side to shade? Because think about it, with one variable, right, we basically pick a point and then we shade to one side. So point and then shade. Two-dimension is the same thing. It's line and then shade. So we draw the line and then we shade to one of the sides. So the question is, do I shade up here or do I shade down here? Now, I know a lot of teachers teach the, oh, if it's less than, it's lower, and if it's greater than, it's above, but that doesn't work here when we're talking about standard form, so you have to use a different strategy. So I just teach one strategy that works for any form. You pick a point on either side, okay, on either side of the line, and test it. Is it true? If it's true, you shade towards that line, or towards the point. If it says something false, you shade away. Okay, I love to test 0, 0. It's easy, right? I would test 0, 0 at any time I could. Okay, test 0, 0. Plug it into the equation. 2 times x minus 3 times y has to be greater than -12. We want to know if this is true or false. 0 minus 0 is bigger than -12. Is it true that 0 is bigger than -12? Yeah, 0 is up here, -12 is way down here. 0 is bigger, which means that's true. So that means we shade towards the point. If it was not true, we would shade away from the point, which would be down here. But since we know this is true, we're going to shade towards the point. Okay, that's basically how two variable inequalities work. It's pretty straightforward. All right, next topic. Let's look at a system. Now that we've talked about two variable inequalities, let's look at a system of inequalities. Okay, so again, this is when we have two or more inequalities. So we're going to have to do the same thing, but we just do it twice. So we're going to graph and then shade. All right, so the solution set, they call it a set because it's a whole bunch of things. The solution set is the region that makes both equations true. So basically, when you test a point in the correct location, the actual solution set, it should make both of the inequalities true, okay? So let's look at a quick example. Y plus 2x is greater than or equal to -3, and x is greater than or equal to y minus 3, okay? I would graph both of these using using zeros, the x-intercepts and the y-intercepts. So we'll graph the first line, okay? So we're going to let x equal 0 and then let y equal 0. So when x is 0, y has to be -3. Okay, when I plug in x equals 0, this goes away and I'm left with y equals -3. And then the second part, when y equals 0, this goes away and we're left with 2x greater than or equal to negative 3. That means x has to be negative 3 halves. So I just solve, okay? So negative 3 halves. So I plot those points. 0, negative 3, boom. Negative 3 halves, 0, boom. Now is it going to be dotted line or solid line? Since it's greater than or equal to, we're going to do a solid line because it's actually allowed to equal that way. All right, moving on to the next example, XY table. I'm going to let x equal 0. If x is 0, the y has to be 3. And think about that. What we're doing is we're saying 0 is equal to, remember we're using equal for just a moment, y minus 3. So y has to be 3 to make it equal to 0. Then we do the same thing with y equal to 0. We get x is equal to negative 3. What I'm saying is x is equal to 0 minus 3. So x has to be negative 3. And I plot those 2 points. So 0, 3 is right here. And negative 3, 0 is right here. Notice it's a solid line because it's strictly greater than or equal to. All right, so what happens is there's 4 regions. There's 4 different locations where I could have the solution set be. There's region 1, region 2, region 3, or region 4. Now, if you want to, you could test points for each equation, like test 0, 0 into the first line, okay? So test 0, 0 into the first line. You get 0 plus 0 is greater than or equal to negative 3. Is 0 bigger than negative 3? Yes. Now I use little arrows here, okay? Just a couple little arrows to show which side I'm shading towards. Then I try 0, 0 in the next equation. So 0 is greater than or equal to 0 minus 3. That's also true, which tells me I should shade towards 0, 0 on this line. So which of these 4 regions has both of the sets of arrows pointing into it? Yeah, it's number 2. So that means this is my shaded region. Now, alternately, you could just, once you graph the 2 lines, you could just pick a point in the like right here. Okay, this is negative 10, negative 10. You could plug that into both equations and see if it's true. But then I think you have to test 4 different locations. And so this way, if you just test 0, 0, you'll know whether to shade towards or away. And you know, if it was supposed to shade away, then you would shade this region or this region, depending on which line it was. So you kind of have to play around with that, but that's the idea there with systems. All right. All right, next topic, absolute value. All right, so just real quick refresher, absolute value of 3 is 3. Absolute value of negative 3 is 3. Negatives disappear with absolute value, okay? Do not think, though, that if you had something like this, that this would be x plus 3. It doesn't work like that, okay? It only goes when it's a number, it makes the negative sign disappear. So this is not true. So that's kind of the basics. So what you're going to have is you're going to have equations with absolute value. That's really what they're going to test you on the test. So they're going to have something like this. Absolute value of 2x plus 1 equals 15, okay? It's really simple. You just change it into 2 different equations because whatever's behind here, right? Whatever's behind this scribble here, what would work? Well, if whatever's behind the scribble was equal to 15, that would work because the absolute value of 15 would equal 15. Or what if what was behind the scribble was equal to negative 15? Wouldn't the absolute value then pop out a positive 15? So what's behind the scribble? It's 2x plus 1. So that means I have 2 equations. I have 2x plus 1 equals 15, and I have 2x plus 1 equals negative 15. Either way, these are going to solve and make a solution. I'm not going to work this out because we're running low on time, but you get 2 solutions usually with this inequalities. You'll get x equals, what would work here, 7, and x equals negative 8. So these are my 2 solutions. You can test those out if you want to, but that's how it works. Make 2 equations. You drop the bars and you rewrite it, just like you saw it here. Then you rewrite it, but you make sure that the second number is a negative this time. Okay. Next thing would be an inequality. Absolute value. So you might have something like absolute value of 12x minus 3 is greater than 15. It works the same way. You rewrite it without the bars. That's the easy part. The second equation you rewrite without the bars, but you flip-flop. You flip the sign, and then you flop the value of the number. So now it's a negative 15. So you solve each of those equations, and again, you'll get two inequalities. And in this one, I think the inequality ends up being, well, let's see. Well, I'm just going to make something up. X is less than 3, X is greater than negative 2, okay? Now, when you graph that, you've got to put it all on one graph. So you have, sorry about that. So you have 3 here, and you have negative 2 here. X is less than 3, and X is greater than negative 2. In this case, it's the area between those 2 points. Depending on the signs, sometimes you get the outside version as well. Okay? All right. Oh, one last thing. If you have something where you get the absolute value of x plus 7 equals negative 3, this will never work. There's no solution here. Because how can you take the absolute value and get a negative? You can't. So just remember there would be no solution to something like that. All right, last thing we're going to talk about is piecewise functions. All right, they're pretty easy. You just have to kind of know how they work. So let's say we have something like this. All right, we have x plus 7 when x is less than 3. We have x minus 2 divided by 4 when x is between 3 and 10, and x squared when x is greater than 10. Okay, so what this means is you break it up into 3 pieces, okay? You break it up into 3 pieces. In this first region, okay, is where x is less than 3. In the second region is where x is between 3 and 10. And in the third region, you're going to have the graph of x squared. So what happens is, right, you'll get 3 different graphs. You'll get this graph here, and I'm just making this up. This isn't going to be very accurate, with an open circle like that. So maybe this is your first equation, and it's not actually equal to the endpoint because it's not less than or equal to. And then over here, maybe you've got your second equation. It does something like this. And then your third equation does something like this. So 3 different parts. So what they're going to ask you is like, what is f of 4? Well, which of these 3 partitions, right, if we break it up into these 3 pieces, does f of 4 fit into? Well, is it x less than 3? No. Is it between 3 and 10? Yes, which means we plug it into here. So we do 4 minus 2 over 4, we get 1/2. Okay, so that's basically what a piecewise function is. It's just a function broken up into several sections based off of a domain restriction on each one. So it's defined over here with this function, it's defined here with this one, and defined here with this one. And that's basically it. They won't ask too much about it, but it's just good to kind of be aware of what that says. All right, thanks again for being here, and we'll see you next week.